Absolutely, Camila. Thanks a lot for the very nice introduction. Just a small remark. Unfortunately, we are not co-located with Werner. I am located in the Netherlands, and Werner is located
Oh,
indeed in Germany.
we actually plan to host the Women's Football World Championship in a couple of years. Germany, Belgium, and the Netherlands together, but so far they are only united by the EU.
Exactly. So I hope by now you can see our screen. And with that, let's kick it off. As it is already 9:01 here in Netherlands, 3 in other time zones. So welcome all. Thanks a lot for being here today with us. Just a short introduction. We're going to compare Java persistence frameworks for NoSQL databases. Our agenda is quite tight for today, so let's quickly meet each other. Werner, who are you?
I'm the Jakarta EE committee representative in Eclipse Foundation in Jakarta EE, and I'm an active participant in several other open source projects, for example, in the Java community process, leading several Java specs.
That's good. Also a short intro about myself. My name is Thodoris Bais, or Thodoris Bais in English, originally made in Greece, living and working in the Netherlands for the last 5 years. I work as a Scrum Master for the ABN Amro Bank. I'm also running the Utrecht Java user group here in Utrecht. And of course, in my free time, I help people find their own motivation in career and life. Something before we start diving into the presentation, we always appreciate feedback on our presentation. So feel free to reach out to us via Twitter. And also during the session, we really encourage you to shoot any of your questions using the chat in this session, in this Zoom session. So one more marketing slide, because I have already mentioned that I'm working for the ABN Amro Bank. So basically, we are hiring. So we are currently moving towards a sustainable and a future-proof bank. So feel free to have a look at our current and open, of course, vacancies, and reach out to me if you're interested, because also in my department we are hiring. Enough about it. Let's quickly move forward. We are in 2020, right? And let's be honest, we had a tough year so far. But there are also a few trends for 2020. So first of all, nowadays, more customers are going online. Another trend is also that the internet is connecting everything nowadays. A third trend is, of course, that big data is getting bigger and bigger. One more trend, apps are moving to the cloud. And the fifth one, of course, the world has gone mobile. What does this mean actually? It means that new digital trends create new technical challenges. And what are those challenges? First of all, we need to develop with agility, right? Second of all, we need to operate at any scale. And last but not least, we need to also deliver the performance and availability required to meet the demands of digital economy businesses. Now, I'm quite curious, what are the advantages of NoSQL at this moment? First of all, NoSQL can handle large volumes of data at high speed with a scale-out architecture. It helps us store unstructured, semi-structured, or structured data. It enables easy update to schemas and fields. It is, of course, developer-friendly, and it takes full advantage of the cloud to deliver zero downtime. Why this talk, though? I'm quite curious at this moment. So do you? I'm pretty sure about it. First of all, as we all know, the JVM can cope with heavy loads nowadays. However, there are tons of persistence frameworks out there, and especially Java specific, of course. So here comes the question, which one performs best for your case? It would normally take ages to compare all of those, so we did it for you. And this is what we're gonna see today. Just a quick overview of what NoSQL databases stand for. Of course, we are talking about database that doesn't use structure nor any transaction, and it is also based on the Bais concept. Werner will tell you more about it later on. Also, about the very last point, Werner will tell you more about the 4 different types of NoSQL databases. Speaking of Werner and of the topics we still need to cover, Werner, over to you to start unveiling this entire schedule for today.
So the key value store is the first type of database. Actually, you just saw another example by the previous speaker. Other popular examples would be Amazon NoSQL databases like Dynamo or S3, Redis or Hazelcast. Then there are column-oriented systems, Cassandra probably being the most well-known example, DynamoDB or Apache HBase. They're probably closest to traditional relational databases, which is why sometimes you also find solutions by vendors that are bigger in the traditional SQL databases. Then there are document-based systems using document formats like JSON, or in some cases, you may also see other formats, including XML, but JSON has become the predominant format. Apache CouchDB, Couchbase, and of course MongoDB, which is pretty much the leading document-based solution. Then there are graph databases like Neo4j, Hypergraph, and others. They have certain specialties that are along the lines of graph-based solutions that you also see, for example, the graph query language introduced by Facebook. And then last but not least, we have the shapeshifters, if you want, multi-model that support more than one concept, sometimes even in the same database. So let's compare them. Here we have the main acronyms in the traditional SQL world, like a table, row, column, and a relationship. In key value, there's a bucket and a key value pair. In column, there's also a column, which is similar to the traditional SQL standard. With documents, there are collections, documents, also key value pair. And in graph, you usually have either a node, a vertex, and edges. There are 2 major concepts, one called Bais, basically available, soft state, and eventually consistent, as well as ACID, stands for atomicity, consistency, isolation, and durability. Then there's the so-called CAP theorem for consistency, availability, and partition tolerance. And here you see some examples for traditional SQL databases as well as NoSQL databases where they are located in this graph. Furthermore, there's scalability versus complexity. And you see the 4 major types of NoSQL databases, which one is more scalable and which one is more complex. In the traditional relational application, you usually have a logical tier, a data access object, and then layers below, including JPA or JDBC on the JVM. For a NoSQL application, the general structures are similar, but in most cases, you don't have something like JDBC or JPA as of now. That's why you often need specific APIs that are specific to either Neo4j, MongoDB, and all the other systems. So in an extreme case, you may end up having to support 5 or more different APIs in your application just because you want to support multiple different vendors. So we are comparing Spring Data, Jakarta NoSQL, that's what Diana Duke stands for, Micronaut, as well as Micronaut Data, although we'll come to how far it supports NoSQL at the moment, and Hibernate, especially Hibernate OGM. And for the sake of time, we are only going to cover Neo4j and MongoDB here in our real-life examples, but all of these support at least these 4 major players, and many of them also support quite a lot more. So what are the problems applying JPA and traditional relational persistency frameworks to NoSQL databases? You have async storage and callback, time to live. You have a consistency level, and in many cases, it's based on the SQL language, whereas on the NoSQL side, you have a large diversity with sometimes not always fully compatible concepts. For example, you would have a graph with edges, and on the other hand, you would have a document and properties. Most of the solutions that we are going to show and that we took a look at support the concept of annotated entities. It may not always be called entity, especially several solutions differentiate even to the extent that they are not fully compatible. So you may have a Mongo entity versus a Neo4j entity. Some of them try to find a common denominator, for example, use something like document entity as opposed to graph entity. And if you simply call it entity, especially the ones that are compatible with JPA. And then you have a concept of column or property, and a few other annotations that are sometimes specific to a particular system. Then there's the template pattern and the templating mechanism that's applied to almost all of them, especially the major players like Spring Data or Jakarta NoSQL. As well as the repository pattern. Here again, we have the example of the Mongo repository as it's defined by Spring Data. Now looking at Jakarta NoSQL, there the dependency injection uses CDI. That's why you usually see the add inject, where in the Spring world, they're compatible, so you can usually also use inject, but Spring historically prefers its own auto injection, but you can use both of them. In Jakarta NoSQL, since it's based on the Jakarta EE spec and CDI, you would usually use add inject. And annotations like at database for the database definition, and then you define, for example, a repository in this case. You can use queries to be more flexible. For example, a query like select star from person. Then there's great diversity supporting additional annotations that are specific to a particular system. So here, for example, we have the common ones like entity or column, and then we have very specific ones that are special to Cassandra and only defined in the Cassandra driver and Cassandra layer, like UDT or CQL, allowing you to do certain things that are specific to, for example, Cassandra, or maybe in Neo4j, you may have similar special annotations that allow you to perform graph query language annotations that only make sense for a graph database. We also support query by text. It's closest to, for example, something like a sort procedure or plain SQL queries in traditional SQL systems. Now let's look at the next player in our endgame, Micronaut, which has been around for not that long actually, but it got a lot of momentum recently. Most of its creators come originally from the Groovy and Grails world. There's a Micronaut Data module similar to Spring Data, but with a little caveat. At the moment, the NoSQL support is not done directly in Micronaut Data, so they are working on that. But there's lower level support for the specific APIs for all the major solutions, including MongoDB, Neo4j, Cassandra, and a couple of others. So this is why the repository currently in Micronaut does not require any annotations. And usually there are also no base types to inherit from, unlike most of the other systems that we're going to look at. Same for the entity. It's just a plain poacher object in this case. And you can have query by text here, for example, graph query specific to Neo4j. Now let's look at a little bit of code. For the sake of time, we're going to show some systems supported by a particular framework. First of all, Jakarta NoSQL, supporting the repository pattern. So here you would have a God repository. And if you do the same with the template, you will notice that they are not so different. Actually, the only difference here right now would be that you replace the word template with repository or vice versa. Most of the other operations are very similar. Now again, here we have the next example. The Jakarta examples all run on Java SE. So you could create a fat jar or run it in the console or even a standalone application. And here's another example of using Neo4j with the actual graph relationship. So here you would have the access to the so-called vertex in Neo4j. Jakarta NoSQL for some systems, especially Neo4j and other graph-based solutions using the Apache Tinkerpop project, it allows to run those in memory. So you can actually run some of them, including Neo4j, without actually having to install Neo4j. For others, you will usually need the database. But you can also run it in the standalone mode. So this one's running against an actual Neo4j system, backing it. And here you get the last one.
Werner, maybe for the sake of time, we should start proceeding to some Spring Data examples as well.
Just 1 second for Micronaut. That one was actually started already. So here you see the Neo4j graph definitions. And let's run this against Micronaut. So we count the cities and let's just run one more query. That's basically to get a particular city that you just saw in the graph. So over to you.
Yeah, if you can stop sharing so I can take over, that would be great.
Oh, it's just, here we go.
Yeah.
So you should have it now.
Sure. Yeah, looks good. Let me just go directly back to the presentation, actually. So Werner has already showed you a few things, and let's see what we can cover in the next 7 minutes. More or less, he covered already all the flavors of repositories and templating and different patterns that are used among the different frameworks. So the logistics and domain for Spring Data and MongoDB is quite straightforward. You just add the Spring Boot starter data MongoDB, and yes, we went directly for the Spring Boot dependency because Spring Boot is quite widely used nowadays from most clients. Of course, we still need to add some dependencies, some application properties. In this example, and as Werner showed you earlier, we're using a mythology database just for the purpose, just for the sake.
Is it just me, or are we not seeing your slide?
Oh, is it? You're not seeing the slides?
No, at least I'm not seeing it.
Oh, maybe.
Not at the moment. Can you try share again?
Yes, I'm gonna share again. Okay. So.
Now I see your ID.
Okay, I'll go directly to the IDE because I've already spent quite some time. So application properties I was mentioning, right? So we're using a mythology database, just a very sample database with 2 properties, port and mythology, and everything comes out of the box with just a couple of annotations for your data, for your Spring Data MongoDB connection. So here comes all the magic, your document annotation for your model. So that way, we're actually telling to our MongoDB connector that we're gonna connect to a GODS database. In the repository, as Werner showed you, nothing that crazy, right? So we're just extending a Mongo repository to use as an interface, of course. And in the controller, no magic at all. Our typical REST controller, right? So just a REST controller and some request mappings. No magic at all here. No extra annotations specific to MongoDB. I have already started the Spring Boot server. And just for the sake of saving some time, these are some sample data. So with that, I will also pull my Postman just to show you how things are going here. I hope the database is still running. Yes. And this is how it goes. As you can see, the requests are going. Now we are requesting for a specific god by name. And of course, if we want, let's say, to delete a specific god by ID, I have already created this request here. Just for the sake of time, let's see how that goes. I should get one record less, which is the case, right? So solid do has been removed. So not enough time, we will post everything later on via Twitter. You'll see the links to our GitHub repository to see more about the example. And with that, let me just move to just quickly to also show you a bit about the MongoDB database. So basically, Neo4j DB comes together with a movies database pre-set up for you. So once you start your Neo4j instance, you will see a movies database set up for you. So I have set up everything here. For the sake of time, I will show you the movie entity. Just a node, everything works in nodes in Neo4j. Same goes for person entity, different node, and of course the movie repository, which needs to extend from reactive Neo4j repository. This is of course a framework specific or a dependency specific or database specific, of course. So, and some roles here. So one more annotation you need to keep in mind, the relationship properties annotation. You can find more about it in the example. I'm not gonna show you more from the code at this moment, because looking at the time, we're really running out of time. So back to the presentation, and while it's loading, Werner, is it visible now?
Yes.
Great. So, and while it is loading, as I was saying, I know due to time, maybe we have not been able to show that much. Please stay tuned on our Twitter accounts. We will post everything online. You will also find a link to our GitHub repository at the end of these slides. What about Hibernate OGM? What happened to this one though? We also gave it a try, right? So far we talked about Micronaut, we talked about NoSQL, of course, and about Spring Data for MongoDB and for Neo4j. What about Hibernate OGM for MongoDB? You will see the old-fashioned style of persisting data with transaction managers and all this kind of stuff. I personally got allergies. And of course, over to our conclusions. So about the NoSQL, it is still in progress, of course. However, it does remove much of the boilerplate you're already familiar with or not, and provides a cleaner and more readable DAO. It supports a huge number of NoSQL database systems, and of course, it is loosely coupled. It has a loosely coupled code, which makes switching between different NoSQL vendors just a matter of configuration. What about our conclusions for Micronaut? Also still in progress, switching between different NoSQL vendors, not so easy. In addition, Micronaut Data does not support NoSQL databases yet. However, it is often faster with a lower footprint. Polyglot, it does support polyglot language for Java, Kotlin, and Groovy. Now, over to Spring Boot and Spring Data, right? Spring Data actually removes a lot of boilerplate code. It provides a cleaner and more readable Java implementation. It does have a loosely coupled code, which makes switching between different NoSQL vendors just a matter of configuration. However, only half a dozen wider. It is only half a dozen wider used NoSQL databases, and only half a dozen were there used for NoSQL databases, and of course some others require more effort or will not work yet. As I mentioned about Hibernate OGM, it does have outdated documentation. And of course, using a mapper for all scenarios is not a recommended approach. However, some JPA concepts are not easily mapped to the SQL world. And of course, it is not error-safe way. It does not provide an error-safe way to run the query language and hydrate DTOs from the results the simple possible way.
In fact, it hasn't even released a major release for the last 2 years. So it's not only the documentation that it seems outdated.
Exactly. So it's not only about the documentation, even the support from the community is not there for the last 2 years, as Werner correctly pointed out. So here are the links to the JNoSQL project, but also to our GitHub repository, where you will find all the code examples we just showed, or that we were not able to show due to limited amount of time. For now, some credits to flatiron.com for being able to use some icons for free, and of course to Michael Simmons for helping us out with these solutions. Thanks a lot for your time. And of course, feel free to follow both of us on Twitter. We are quite active to also answer any kind of questions. Camila, sorry if we exceeded your time.